Hello, I'm Stephen Lee, and welcome to Omics Quest. In today's video, we'll explore Ultima's paired plus-minus sequencing or ppmSeq, an innovative method that provides an error-corrected, cost-efficient, and scalable approach to high-fidelity whole genome sequencing using duplex sequencing. This technique can apply to challenging clinical applications such as whole genome sequencing-based minimal residual disease monitoring, as well as emerging frontiers in human somatic genetics, where high accuracy is critical for mutation identification. Let's break it down. This video assumes you already watched two other Omics Quest episodes, Inside Ultima Genomics flow-based mostly natural sequencing by synthesis, and Inside Ultima Genomics whole genome sequencing with low substitution errors. For early cancer detection or MRD monitoring from blood, you run into a challenge. Circulating tumor DNA is hard to detect because cell-free DNA is so scarce. Currently, targeted panel sequencing is the standard method for detecting circulating tumor DNA in clinical genomics. It focuses on a small number of known mutations, but sequences them at a high depth, enabling the detection of mutations with low variant allele frequency, and it is much cheaper than whole genome sequencing at an equivalent depth. However, because cell-free DNA is so scarce, the available genomes are quickly exhausted, resulting in redundant reads of the same molecules. As sequencing costs continue to fall, now as low as $80 per 30x whole genome sequencing on the Ultima Genomics platform as of September 2025, WGS is increasingly replacing targeted panel sequencing due to its simpler library preparation. WGS prioritizes breadth over depth, reducing reliance on a limited number of sites in low tumor fraction settings. However, standard WGS remains too error-prone to reliably identify rare mutations in cell-free DNA. Let's look at an example. Imagine some cell-free DNA with a real mutation, like the one shown here. There are many ways sequence reads can end up with artifacts. That's where ppmSeq or paired plus-minus sequencing comes in. Powered by the Ultima Genomics platform, which employs emergent PCR for clonal amplification, ppmSeq natively enables scalable duplex sequencing. In essence, it distinguishes true variants from artifacts by reading both strands of a double-stranded DNA molecule, since most artifacts appear on only one strand. However, it's not just emulsion PCR that enables ppmSeq. Ultima also designed bubble adapters to differentiate between the Watson and Crick strands while simultaneously reading them together to generate a final consensus read. Let's look more closely at the bubble adapters. Here are the sequences themselves. Since double-stranded DNA is partitioned and clonally amplified through emergent PCR on sequencing beads, both copies of the Watson strand and the copies of the reverse complement of the Crick strand are simultaneously read in a single sequencing read. In a scenario where both Watson and Crick strands are correctly captured and amplified equally, we would see a 50-50 mix of A and T sequences at the bubble positions. This allows us to confidently filter out artifacts that appear in only one strand. In another scenario where both Watson and Crick strands are captured but one drops out, so to speak, we'll see only A or T sequences at the bubble positions. In this case, we cannot reliably distinguish true variants from artifacts. Therefore, our goal is to minimize the occurrence of these dropouts. Here's what the distribution of single versus double-stranded reads looks like. Note that ppmSeq achieves a superior duplex recovery rate of 44% compared to 5 to 11% with leading duplex technologies. It also delivers a duplex yield that scales linearly with sequencing coverage across a wide range of DNA inputs. Nice! Thanks for watching Omics Quest. If you enjoyed this video, please like and subscribe to the channel.